Hi, my name is Faik Hazik bin Muhammad Zaidi and my student ID is 2024209726.
Hello, my name is Urmilana Coutinho and my student ID is 2022475148.
Hi, my name is Hud Saleh Armani bin Naimi and my student ID is 2024293128. Hi.
Hello again. As you can see, the title of our video presentation is Techniques of Differentiation. Before we dive into the different technique, let's start with the basic. What exactly is differentiation? It is the process of finding the derivative of a function, which measure how the function's output changes with respect to changes in its input. Now let's move to the techniques of differentiation. For the first one is power. If you have a variable raised to a power, just bring the power down as a coefficient and subtract 1 from the exponent. For the second rule is product rule. It is used when you are differentiating the product of two functions. You take the first function times the derivative of the second, plus the second function times the derivative of the first one. And the third rule is quotient rule. It is a rule for dividing one function by another. You differentiate the top and the bottom separately, then apply the formula. And the last one is chain rule, where it's used when you have a function inside another function, where it is a composition. You take the derivative of the outer function and multiply it by the derivative of the inner function.
So we move on to the question 2. Find dy dx for the following functions. A. Y equal to 4x power of 2 cos 5x minus 2. So, to make it simple, we're gonna use product rule to solve this kind of question. Firstly, you need to find u and v. To make it simple, the first one is u and the second one is v. So, 4x power of 2 is gonna be u and v is cos 5x minus 2. After you find u and v, you need to find the u prime and v prime for it. So use the differentiation technique, that is gonna be 4x power of 2 gonna be 8x and v prime from cos 5x minus 2 gonna be negative 5 sin 5x minus 2. So after you find that u and u prime, v and v prime, put it in the formula, and after that make it simple until the simplest answer. So that's gonna be your answer. So we move on to the question 2, that is B. Y equal to 3x plus 1 over sin 2x. So this is the different formula that we're gonna use, that is chain rule, but it's the same, that you need to find u prime, v and v prime. If you see the first and the denominator, the upper one will be 3x plus 1, that is gonna be u, and the denominator will be gonna v. So you differentiate each and gonna be u prime and v prime. After that, you gonna use chain rule, and you just put in the rule. So make it simple and find the simplest answer for it. That's all.
Question number 3. Given y1 is 2x minus e5x plus 3 is equal to tan 6y. So the question asks us to find dy per dx using implicit differentiation. So first thing first is we need to differentiate both sides of the equation with respect to x. So we need to differentiate the left hand side with respect to x. D per dx bracket y1 2x minus e5x plus 3 equal to d per dx bracket y1 times 2x and bracket minus d per dx bracket e 5x plus 3 bracket. So we will be using the product rule for the first term and the chain rule for the second term, and we will get dy per dx ln 2x plus y 1 over 2x times 2 minus e 5x plus 3 times 5. So it will be dy per dx ln 2x plus y over x minus 5e5x plus 3. So y will replace the number 1 on the top, and the times 2 will remove the number 2 from the x. So for the second picture, we need to differentiate the right hand side with respect to x. First is d per dx times tan 6y equal to sec to the power of 2 6y d per dx 6y equal to 6 sec to the power of 2 times 6y dy per dx. Now we will equate the derivatives of the left and right sides. Dy per dx ln 2x plus y over y per x minus 5e5x plus 2 and equal to 6 sec to the power of 2 times 6y dy per dx. And then for the last step, we will solve for dy per dx. So if you guys look at the second picture, we will write like this: dy per dx ln 2x minus 6 sec square times 6y dy per dx equal to 5e5x plus 3 minus y per x. And then after the calculation, it will be ln 2x minus 6x square times 6y. Look, the dy per dx is gone. After that, it will be equal to 5e5x plus 3 minus y per x, and the last answer will be dy per dx equal to 5e5x plus 3 minus y per x over ln 2x minus 6x squared times 6y.
Question 4. Use linear approximation to estimate the value of cube root 63.98 minus 2 over square root 63.98 correct to 3 decimal places. Step 1. We have to determine the function of fx and gx, where fx is cube root of x and meanwhile gx 2 over square root of x. The value of x is 63.98. For step 2, find the suitable value of x0 and delta x. To get x0, we have to choose a value that is closer to x0, where 63.98 is close to 64. To get the delta x, we have to minus x with x0. Then the delta x is negative 0.02. For step 3, we have to differentiate the both function. As you can see, the solution is already in there. And for step 4, we have to substitute x0, 64 into the function and derivative. Lastly, step number 5, we have to substitute all the related values into the formula. I mean, all the values that we already got, then we substitute it into the formula. Then, now we approximate both functions at x equal to 63.98. After we substitute the value and calculate it, we subtract the two functions, that is fx minus gx. Then after we get the answer, we rounding it off to 3 decimal places, and the final answer is 3.750.
To sum it all up, in calculus, differentiation is one of the basic techniques and it is used to measure how a function varies. It equips us with the means to measure rates of change, find slope of a curve, and address various real-life challenges like movement, expansion, and approximation. And also, it is recommended that learners develop a strong conceptual and procedural foundation in differentiation techniques early in their calculus studies. That's all. Thank you.